Hey guys, today we are going to run through the video that everybody has been asking for. We talk to hundreds of people every spring on 1910 air carts, specifically double chute air carts, and they have a major problem. And the major problem is almost always with, hey, I can't meter light crops. I have problems hitting rates with oats. I'm having skipping in the field, I'm having misses in the field, I'm constantly plugging, enough to drive guys wild. And what we're gonna touch on this video is the biggest problems with your 1910 air cart. To start this video, we need to be talking about tank pressure. And so everybody has issues with, now we get calls every spring. It's like, hey, I'm trying to seed oats, I'm trying to seed canola, I'm trying to seed, even wheat crops, fertilizer will have tons of problems if we don't have correct tank pressure. What I'd like to spend this time talking about is how the whole tank pressurization system works on a factory air cart and how it works on a upgraded air cart with some of the Agri stainless parts that we carry and manufacture, and how we can solve all of our problems and not have any problems come spring when we're trying to seed. We can respray our crop, we can combine our crop, but we can only seed once. And you only have one shot at getting in the crop, and if you don't find out that you have all of these issues, like you had skips in the field, you had a wave or a flicker in the field caused by varying rates or surging, and we don't realize that until the crop comes up, we're in a really poor position for the rest of the season. So we always need to get these things nipped in the butt right away, and we need to make sure we have a flawless cart coming the seeding season. Whatever it takes to have a flawless seeding tool, that is what we need to be doing. The biggest issue and the questions that we constantly answer on the 1910 air cart is a lot of times related to tank pressure. So we're gonna run over that a little bit today. And so first, we're gonna be talking about the theory of operation. And so we have, on a 1910 air cart, we have these really fancy, this is the older style tank pressure gauge. This reads the pressure inside of our tank as well as the pressure in our lower manifold area. And we rely on these heavily. Now, a lot of guys say that, well, mine don't work, they've never worked, and we're gonna touch on that too. So these pressure gauges are typically mounted on the front side of this cart, right about here, about 80 feet away from the tractor itself if you're a tow behind cart. It's fine if you're a tow between. If you're a tow between air cart, you can see them pretty fine on the tractor side. But we're a tow behind cart, so what we've done is we've actually relocated the gauges to the front of the hitch of the drill so we can see them a little bit better from the tractor. Another way of doing that is you can set up a camera system. A lot of guys have cameras in the tanks anyways. We can add a camera and point a camera at our gauges with a light, so we can always see them day, night. And we'll touch a little bit more on that here shortly. But first we need to talk about theory of operation. So we're gonna do a quick synopsis on how an air cart functions, how we meter, how tank pressure is related to that, and what issues John Deere's have and how we can fix it. So first of all, in a pressurized air system, this is not a grain drill where we have gravity flow. We have a pressurized tank, and we have a pressurized manifold assembly that delivers product to our manifolds on our drill as well as to our openers to be placing product in the ground. The theory of operation is my meter cartridge is going to be entering here. So this is our metering roller in here, and this is what's going to be responsible for metering product into our manifold assembly, into our piping, and therefore delivered to the opener. So we have a high pressure, not a high pressure, a low pressure, but it's higher than atmospheric pressure. Our pressure in our piping or manifold here needs to replicate the pressure inside the tank. And what I mean by that is I'm just going to start throwing a few numbers here and we'll go over it a little bit. We move product here at a high velocity and a low pressure. We're not talking about 10, 20 PSI in this manifold. Typically 1 to 2 PSI. Let's say we have 2 PSI in this manifold or in this top run of piping here and going to our opener assembly. If we have 2 PSI in this in this pipe right here, I'm dropping my front tank of product, let's say it's wheat, and we're dropping wheat into the top tank, I also need 2 PSI in my tank. And the reason I need that is because I have air being flown here at 2 pressure trying to get out of the pipe. And if I have only 1 PSI of product in my tank, my product is gonna not wanna flow through my meter cartridge. Air is going to wanna come up, and it's gonna be a path of least resistance. Essentially, it's gonna be trying to fill my tank and trying to get my tank to 2 PSI, and we're gonna start to see bridging issues. Trouble hitting rates. Our meter roller is still moving at the same speed, but we're not getting as much product down into our airstream. And that can be due to a lack of tank pressure. Now you'll start to see this as an issue is when, if you've ever left the lid open on a tank, you leave a lid open in your front tank, your middle tank, your rear tank, doesn't matter, you lose your tank pressure. And even if you've got a pretty large air leak, maybe you have a lower tank pressure in your tank. So if you have a lower tank pressure in your tank, all of a sudden you realize, well, I'm not hitting rates, or holy man, I've done a few passes and the tank's not going down. Oh, I bet you I've left the lid open. That's essentially what we're doing. And a lot of the problems with these 1910s is exactly that. Essentially, we've left the lid open, but we're choking off air pressure to the tank. So I'm gonna essentially talk a little bit about here, we'll talk about a 2-tank cart. We'll go over our plenum assembly and how that works, and our baffle assembly in there, how that can be thrown into the mix as well of causing some issues. We're just gonna throw out a random scenario here, kind of an out to lunch scenario, but it helps paint a picture in a lot of people's minds. So on these front 2 tanks, I'm seeding 2 products. I have fertilizer in my front tank and I have seed in my middle tank. I'm going to be putting nitrogen down in my front tank at a rate of 200 pounds to the acre. And I'm going to be putting down 100 pounds to the acre of oats in my middle tank. This is a random scenario, nothing that's probably going to be done in real life. But 100 pounds of oats in my middle tank, 200 pounds of nitrogen in my front tank. It's going to take a lot more velocity and a lot more wind power to push 200 pounds of heavy bushel weight or heavy product density nitrogen than it will oats. The way that I'm going to help adjust that is, let's say I'm putting oats down to my seed row and putting nitrogen down to my mid-row banders on my double chute air cart. The way I'm going to achieve that is I have my plenum back here, and we'll cut to that and how that works. But I have my plenum back here, then I have a baffle that raises up and down. And so what I'm doing there is I'm taking the air velocity from my fan and my wind from the fan, and I'm directing it more to the top chute or to the bottom chute to help even out product density and the velocity of which it makes it to the opener. And so I need a lot less wind to move 100 pounds of oats than I do to move 200 pounds of nitrogen. Typically, I'm always going to put the lightest product into my top run. I'm going to put 100 pounds of oats into my top run, and I'm going to adjust more air to be pushed down into my bottom run to push 200 pounds of nitrogen on my front tank. Now in doing that, I've also changed the pressure in which the manifold assembly is at. So I'm just gonna throw out some random numbers. Let's say I have 1 PSI now on my top run and 2 PSI on my bottom run of pipes. So by doing that, I now have to change what pressures my tanks are at. So now my middle tank has to be pressurized at 1 PSI. This tank will have to be pressurized at 2 PSI. And so the way that a factory cart does, well, just come with me here. The way that a factory cart will do this is, I'm just gonna squeeze you in here, and we have a tank pressure air line coming off of our top run, and we also have a tank pressure air line coming off of our bottom run. And by running these air lines will be running to our manifold assembly here, and they'll run into this manifold on this side. The top air line will run to my passenger side or my non-auger, non-conveyor side of the cart. My bottom air line will run to this side of the cart. When I select top chute or bottom chute on a factory system, I'm selecting where I get my air from. So again, I've got 1 PSI in my top run, 2 PSI in my bottom run. So I've taken 1 line from each, and I run 1 line to each side of this manifold assembly. Now what a lot of guys don't realize is there's a selector valve in here, and when I pull for top chute, I'm opening up a gallery from the top chute pipe, and I'm going to be supplying air into here, and there's a passageway through my meter housing right here, John Deere meter housing as well as aftermarket meter housing. We have a passage through here, up through this back wall is actually 2 pieces, and there's a gallery through here with an orifice. And then we're going to come up into here, another gallery, through a seal, through a funnel, through your ladder, and finally we get to the tank. And so there's this very convoluted way of getting to the tank. Now it works, it absolutely works, and it works for quite a long period of time. And then what starts to happen is we start to have these air selectors plug up with product and with dirt that our fan is pulling in, okay? So that's gonna be one restriction. We're also pulling in dust and dirt and fertilizer, going to start filling up our meter housing. Now on an aftermarket meter housing, we have a plate here to remove and clean out this plenum assembly in our meter housing. But on a factory John Deere OEM meter housing, we do not have that. So this whole back wall will start to fill up with dirt and dust. And when you overfill your tank, it'll get into the top of our ladder posts and dust swirling every time we fill. It'll start to fill down into the tops of your ladder posts. This happens not in year 1, not in year 2. This is 4, 5, 6, 7, 8, all the way 11 years, you know, guys are starting to have these issues. All of a sudden, if we start to plug off this wall in this meter housing that we can't get to, all of a sudden we're choking off tank pressure to the tank and we can't meter. It's not because you've left your lid open anymore. It's because we have a blockage in our tank pressure system. We could have a blockage in our valve here. Or first, you know, we could have a line off, no problem. We could have a line off. We could have a blockage in our metering housing, blockage in the seal here where it meets to the ladder or your lower funnel assembly and your lower ladder mount. You could have a blockage in our ladder posts. And what's gonna happen here is we're trying to go seeding, we're trying to beat a rain. We got a rain coming in a couple days and we need to get product in the ground, but we don't have tank pressure and we can't seed. So all of a sudden we have a very large issue on our hands. We remove our manifold, we remove our meter housing from our cart, all our pipes gotta come off. So we remove our meter housing from our cart and we got a factory John Deere meter housing on there. But now we can't get in that orifice area to find our tank if it's plugged or not. We can't physically access it. We can put a blowgun through it, but that's about it. Then maybe our funnel has to come out or we gotta shove a broomstick through our ladder post to make sure our blockage is here. Meanwhile, we've wrecked the seal between our manifold and our meter housing and our mounting plate, and our funnel seal. We've potentially wrecked all of this in the meantime. And now we have to run to our John Deere dealership. Hopefully they have a seal. We got to put it all back together. And meanwhile, we're trying to be seeding. And this can be a 2-day, 3-day, 4-day ordeal trying to get your cart fixed when it's time to go. And it worked last year, but it didn't work this year. But every year inside, we get a little bit more corrosion. We're choking off more and more air. All of a sudden it's a problem. Hopefully we catch it before seeding. Hopefully we don't catch it when we're trying to go seeding, and even worse, hopefully we don't catch it after the crops came up. And so we're gonna talk a little bit about our tank pressure kits. What every single double chute John Deere air cart should have from factory. And so you'll notice if you were to look at a new series of John Deere air cart, C series is what I'm referring to, and the newer 1910s, we have mounted valves on the side of the cart. John Deere has recognized that this is an issue and it needs to be corrected. And we don't want growers to have issues in the field, bottom line. What we've done, what John Deere has also done, is we've installed tank pressure kits. Agri stainless tank pressure kits are very inexpensive. They, at the time of this video, they retail for about 280 or 290 Canadian dollars. And it comes with all the pieces you need to retrofit this cart to the new series or new style of tank pressurization systems. So what I'm gonna do in this video, or what I'm gonna do in this valve, essentially is get rid of our tank pressurization system through our meter housing, and I'm going to run it external. You're a guy running a John Deere single chute air cart, you really don't need to watch this video because you don't have issues. Typically guys with a John Deere single chutes don't have issues. Unless the hose physically comes off, they don't run into issues. And the reason is because we only ever are dropping into one stream, a single chute airstream. So I run a hose directly from my pipes back here at my plenum, and I run a hose directly into my tank, and I run it up the ladder post, and I run it to a diffuser underneath the lid, and I always have the proper tank pressure, so I don't have issues. And those guys are problem free. And that's what John Deere tried to replicate with a double chute, and what we've done as well, is now what we've done is we've run all external tank pressure routing. So I'm running 2 lines you can see here from my manifold or from my plenum at the back of my cart from my tank pressure lines that are welded into those 5.5-inch pipes. And I've ran them up here to my valve. Now in here I have air coming in from the bottom chute I have air coming into the top from the top chute. And I've routed the lines really nice, so it's very clean and tidy. It looks very factory, it looks very nice. And then I have my exiting line. Now this line is going to be run on the other side of the cart into the tank, and we'll cut to that video now. So here guys, we have our bulkhead coming in, running up our ladder to a diffuser at the top. And then we also have our signal line coming in with our camera harness and our tank level sensor harness. And we're gonna run it all the way to the top of the tank here, to our diffuser for our tank pressure signal line. What this valve is now doing is I'm selecting where I'm getting my air pressure from. So as an example, I want to be dropping, like I said, I want to be putting oats in here into the top chute. So I'm pull here for top chute. I'm now putting product into the top chute. So I'm going to go to my valve, I'm going to select top chute. If I want to put product into my bottom chute, and now I'll select bottom chute. Now what I'm doing there is I'm pulling air from my bottom chute into this valve. I'm closing off air coming in from my top chute, taking the correct air pressure out of here into my tank, directly to my tank. Now the whole reason of this video is to solve all problems. We don't want to have issues coming into the seeding season. We want to have a flawless seeding season. That's always the goal. With this system, we get rid of all of the John Deere aftermarket or John Deere OEM failure points. And we go, unless physically a line comes off, you will always, no matter what, no ifs, no ands, no buts, you will always have correct tank pressure and you will always meter correctly. Now we are just based on, is our roller in good shape? Do we select the right roller? Is our product physically okay? Do we have high moisture product, wet fertilizer? Do we have clumpiness? Do we have lots of fluff, fuzz? Our seed wasn't cleaned well enough. All of that stuff does take into metering issues, and sometimes there's not much we can do about that, and we got to fix our product first. 99% of the time, it is never the product, and the cart can push it through. The cart is capable of doing it, but we suffer in tank pressure. Now we're going to switch. Now we know how this kind of works. Now we're going to switch to the control system side and our signal side. So what I'll reference here is my gauge. So here you have your factory gauge, typically mounted on the front of your cart. Now a lot of you guys will say, gauges haven't worked in years. Don't trust them, don't look at them, don't know. I disagree with that statement. The reason I always want these gauges to work, and I want them to be trustworthy, so you can start to trust them and you can start to use them. Now these gauges are very expensive. They're about $800 a gauge at this time. Now in saying that, they're very high quality gauges. You typically don't replace them very often. Once in a while, if you drop it, you bang it with a hammer, you might have to, sure. But in this gauge, it measures very low PSI. Now what this gauge measures, we have two signal lines running to the back of this gauge here. In this, we also have a overpressurization plug in here, and that is it. So what this gauge is measuring is essentially what we just covered. I have one line going to this gauge here that is coming from the lower manifold, goes to a port on the bottom side of the meter housing on the other side of the cart. And my other line that goes to my other fitting here is this line right here. It runs from this gauge and it's gonna run all the way back into my tank. It's going to run up my ladder posts to, again, a little diffuser mounted underneath the tank. So essentially what we're doing with this gauge is measuring the pressure in the manifold, the pressure in the tank. Go figure. And we're trying to match them. And so with this gauge, we have two pressures that are constantly fighting each other to keep the pin in the center, keep the needle in the center. If I all of a sudden have a higher pressure in my manifold than I do in my gate, or than I do in my tank, my needle is going to start to push towards lid open. Now if I have lower pressure in my manifold than I do in my tank, it starts to push towards check gauge. By now understanding how this gauge works, we can start to understand how the system works, and we can start to understand how to fix it. So if you have your gauge now, and we have tank pressure kits on this cart, or if we don't, but our gauge should always be reading in the center. If your fan is off, tractor is parked, we have essentially atmospheric pressure in our manifold, atmospheric pressure in our tank. Pin should read in the middle. We turn our fan on. We should have the same pressure in our manifold as we do in our tank. If we fill the tank with product and the fan is on, pin in the middle, we have the same pressure at all times. That's what we're aiming for here. When I'm working on this, there's a lot of things that can cause this gauge not to read. Even if we have tank pressure kits on here, we still have a signal side that could potentially cause us flaws. With this tank pressure kit, we've now solved the problem, and we have proper tank pressure at all times, barring the line has not come off. But let's say we're driving down the field and our gauge reads all of a sudden to lid open. Well, then we can stop right there and figure out what's going on. Now we know we have correct pressure in the tanks. We can confirm all of our line routing's right and we're getting air to our tanks, and that's all good. Now what I want to check is my signal side. Maybe what I've done is I've tightened a zip tie too tight and pinched off this signal line. It could be here all the way to the gauge, could be all the way to the diffuser in the top of the tank. Maybe I've over tightened the zip tie in the ladder post. What could have happened too is we could have gauge failure, very uncommon like I said. We could have a blockage in that line. So what I can do is I can pull the line off the gauge, pull the line off the diffuser, leave it on, and take a bit of air, and we want to blow it from the gauge towards the tank and make sure it's entering the tank very easily. Make sure you can hear it in the tank coming through. And we want to check that for both. If I have a lid open reading, that means I have less pressure in the tank than I do in the manifold. I either have too much pressure coming from the manifold, or I have a restriction in the line going to my tank. So I can check that line, we can figure that out very quickly, and our problems are now solved. My whole point of this is if we were to trust our tank pressure, trust our signal side and our gauges, now we drive and we're seating. And as soon as we have a gauge read not right now, we have, at the start of the season, we've checked everything, we've blown out all the lines, we've cleaned everything out, and we have a fully operational double chute proper tank, a cart that's running proper tank pressure. Now when we put the drill in the ground, everything's working flawlessly, and you get 200 acres in, and all of a sudden the pin reads off on the gauge. Well, you stop the tractor right then and there because you trust everything and you figure out why. And as soon as we figure out why, maybe it's a signal line, or maybe it's the gauge, or maybe it's a hose came off, or whatever the case may be, but we can figure it out right then and there, and we can fix it. And then, oh, our gauge works again, everything's great, we continue on seeding, and we know we won't have any issues when the crop comes up. So I just wanted to take that time, explain that a little bit to you. We're gonna show you a little bit inside the tank as well. I really wanted to explain that and make sure we have less issues. So I hope this helps, guys. If you have any questions, please reach out. The phone is always on. You can reach one of our dealers as well. Look on our website and our dealer locator. We are always available. You can check our YouTube for more videos coming out and what to look for on your 1910 air cart, your drills, your flexicals, your Morris, your New Holland, your Seedmaster, everything in between. But we always want to try and help here and get you the best parts. Make sure you have a flawless seeding season. So thanks very much, guys. We'll talk to you soon. Take care.